Hello, everybody. I'm back with some more information on costs. And today we're going to be talking about long run costs. Last time there was kind of an extensive video about short run production costs. I promise this one will be much shorter. But I want to start off with just a quick review, make sure that you absorbed what you should have absorbed. There's a question here that I want you to read through. Take a few moments and see if you can calculate those, and then pause the video and we'll come back and talk about the solution. All right, so this gives you a firm with total cost of $1,500, total variable cost of $750, and a total product of 100 units, and then asks you to find all of these other factors. So the way that you would calculate this: total fixed costs. Remember, you're going to be plugging that number into the total cost formula. Excuse me. So total cost equals your total fixed costs plus total variable costs. The numbers that you're given, total fixed cost or your total cost is 1,500. Total fixed cost is our unknown, and our total variable costs are 750. So therefore, if we solve this formula right here, your total fixed cost equals 750. Average total cost we calculate by taking total cost divided by quantity. So that'd be 1,500 divided by 100, or $15. Average fixed cost, we take total fixed cost divided by quantity, which is 750 divided by 100, or $7.50. And then average variable cost would be the same, because your total variable costs are also 750. So 750 divided by 100 is $7.50. Hopefully, at this point, you've already watched and completed the short run notes. You've already done the practice. If you haven't, I'd recommend you go back and do that and then jump into the video here. But if you have completed all of that, let's go ahead and talk about long run production costs. So I alluded to this in the last video. Long run production costs are referring to the time horizon in which a firm can change all input amounts, including their plant size. So this is no longer the time horizon where we're just working with the fixed four walls that we've got now. This is enough time that we could expand that or contract that. In the long run, all costs are variable, because you can make changes as needed. So we are going to be looking at long run average total cost, and keep in mind that our long run average total costs are going to be derived from different short run average total cost curves. So we looked at all of those different curves last time. Average total cost was kind of a wide U shape, and it was intersected at its minimum by marginal cost. If we take all of those average total costs for various plant sizes, if we start our business over here where our output is lower, this would be my original average total cost. So let's say that I engage in production and I'm like, hey, I could make my plant size bigger. I could add a second factory. So then we have this new average total cost curve that's reflected along our x-axis here as our output increases. Each one of these little red U-shaped curves here represents the average total cost, the short run average total cost for one plant size. If we string all of those together at their minimum, we end up with this much wider U-shaped long run average total cost curve. So remember that these red curves, the reason that they're U-shaped is because that law of diminishing returns, the idea that as you add resources to production, eventually your total product is going to decline, and so your total cost will go up. So the red short run average total cost curves here, they represent the ATC for one plant size. If we string all of them together, we can derive that long run average total cost curve. The long run average total cost curve, while the law of diminishing returns plays into it in the short run, in the long run, we have something called economies and diseconomies of scale. You may have heard economies of scale before, like, oh, well, it's a bigger production, so they're meeting economies of scale. Economies of scale refers to the idea that we have gotten big enough to where our labor can be specialized. Like maybe when you start the business, you're doing everything yourself, but then you hire other people, and each of those people specializes in a certain job. You also can achieve managerial specialization. So instead of managing the whole operation, maybe you have a human resources manager and a operations manager and a accounting manager, that sort of thing. It also allows you to use capital efficiently. So, all those tools and technology that you're using to make things, you are using them most efficiently when you achieve economies of scale. There's also something called constant returns to scale. Like you've maxed out how much specialization can occur, but you can keep expanding and still expect those same results. That's what's called constant returns to scale. So, if we map that out, hold that thought. We'll come back to mapping that out. Diseconomies of scale first. This occurs when you've gotten too big. It is possible to be too big, and what that means is within the way that you have it organized, you start having control and coordination problems. So maybe your supply chain's not working correctly, or maybe you're not communicating effectively. Workers become alienated. They feel like they are a number, like maybe they're not getting adequate training, and there's also a fair amount of shirking that goes on. So we talked about that in the last video, that one employee that stands around doing nothing, getting paid. Um, if the company has gotten to the point where they're experiencing diseconomies of scale, there will be shirking in large numbers. People sitting behind their computers on Facebook all day instead of doing what they're supposed to be doing, and nobody's calling them on it. They're just costing the company money. That's what we mean by shirking. So if we spell that out, this is what it looks like. When we're achieving economies of scale, we're getting bigger and bigger. Okay, so our output is down here on the x-axis. Our average total costs are shown on the y-axis. During economies of scale, as we expand our plant size, expand our operation, we achieve greater and greater size, greater and greater output as we move along this x-axis, but lower and lower costs. So it's all good. Now, this area in the middle of the U shape is what's called constant returns to scale. So, I can decide where along that output horizon I want to be, and any of those points are good for me as far as profit goes. Once I hit this upward swing here, this is where I'm achieving or unfortunately experiencing diseconomies of scale. So my costs begin to increase again as I've got shirking, as I've got coordination and communication problems. So if I'm a business owner, I want to be somewhere in these first two areas. I want to be either at economies of scale or constant returns to scale. If I notice I'm on that upward swing of the long run average total cost curve, it may be time to cut back, close some plants, lay off some people, because I've just gotten to a point where all of that extra production is actually costing me money instead of benefiting my profit. So, key things to remember. Number one, long run average total cost curve, this U shape, is due to economies of scale and diseconomies of scale. Okay. Now, if we go back and look at the long run average total cost curve, how it's derived, keep in mind your short run average total cost curves, these red curves, those are U-shaped because of diminishing returns. So keep in mind both are U-shaped. Short run, U-shaped due to diminishing returns. Long run, due to economies of scale and diseconomies of scale. If you've got any questions, as always, feel free to get in touch. What's coming up next is some review to get ready for a quiz. And so as you begin to study for that, please let me know if there's anything that I can do to help. Have a great day.